These pesky mercs, they've been making a fool of us on the racetrack, but fear not, wee Poppy has got her first car out of storage and we'll get them on the run.
Poppy, what's your car called? A what? A Ferrari?
What about ye? Yes, viewers of the channel may recognise this car. It was in about a month ago with a math code and a DPF fault, found to have a split boost pipe, and that was all fixed. Car was running great, but just back in, customer complaint, engine management light is on, but there's no real noticeable difference in performance. The last time it was in limp mode, and this time it's just the management light. So we'll give it a quick scan and see what we've got. What would cause a math code? I haven't even scanned the car yet, but yeah, definitely needs replaced. So we've come up with a fault in the engine module, but you can't see that, so we'll put it in the big screen. So, fault in the engine management light's on, so that's what we're interested in. I'll have a look, see what it is. Trouble codes. And there we go, P054615, current and stored. The outlet system temperature sensor 1, cylinder bank 1 has a short circuited battery. There's a short circuited battery or an open circuit. So that is the reason for our management light. And if we look, we see it's current and stored. So this is a hard fault and it will not clear. So this fault comes back right away if I try to clear the codes. So we'll have a wee look at the live data to see if we can see anything. Now that description, the outlet temperature sensor, that is talking about the exhaust outlet, so the gas is out. So on just the way this live data is split up, so we're interested in the DPF. Now this car came in the last time with a filled DPF because it had a boost leak. So we'll have a wee look at the live data, see if anything jumps out at us. So yeah, I can see there B19/11. I don't like the look of that number, so that's 850 there. I might be able to see it better now. 850 B1911 temperature sensor upstream. We'll expand that a wee bit and see what that's all about. Temperature sensor upstream of turbo B1911 is 850 degrees centigrade, it's showing. So that is way too high. This engine's basically cold. The B19/9 temperature sensor upstream of the DPF is showing 27 degrees centigrade. So I would say that that is correct. So B19/11 is stuck high. So the engine management light is illuminated, so we should have a code in the OBD side of things, the generic side. So we'll have a wee look at that and see if there's a different description. So P0546, exhaust gas temperature sensor circuit high, bank 1 sensor 1. So it's actually confirming that, tells us a wee bit more, and we'll look at what data you would get on that side of things. And so there we go. Oh wait, look, but doesn't really tell us much there. There's no live data for the exhaust gas temperature sensor, but what is interesting is the engine coolant temperature is 26, and that complies with the other exhaust gas temperature, the DPF one. So we'll have two exhaust gas temperature sensors, one sort of either side of the DPF, one at the turbo and one down at the DPF. So the one down at the DPF was reading 26 or 27 in the other live data, and the engine coolant temperature is 26. So I'm pretty happy that that is correct. The one that says 850 is clearly wrong. So I've only just got this TV on the wall. I was in a supermarket buying bananas, and I came out with a bunch of bananas and this TV, and I stuck it on the wall, and I got a bracket off the Scamazon, and it's great. So it's a 40-inch TV in case you're interested, and I just bought it out of the supermarket. It's an Android TV, this one, and it's I think it's made by Sharp or something like that, but it's pretty generic TV. I think it's made in China, and it's branded Sharp. I don't know whether Sharp actually makes TVs anymore, but the aspect ratio from the MaxiSys here, let's see if I can change that.
I'm sorry, Dave. I'm afraid I can't do that.
Oh, we'll scratch that idea. Okay, we'll have, I don't know what happened there. So we'll have a wee look at some information, and we'll look for this B1911, and there's a location there, and yeah, it's in around the top of the manifold at the turbo. So that's the front of the engine there, with the few vacuum pipes and stuff like that. So that's our location. So yeah, we'll have 45 Newton meters it is. So yeah, that's us. So we'll get a wee look at that. We'll get over to the car and see where this thing is. So from our information, that sensor that we suspect is below this airbox in the exhaust manifold and around where the turbo is. So all the work here is at top, which isn't too bad. And from the picture, I can see the multi-plug is in where these vacuum pipes are at the front of the engine. So there's our vacuum pipes. We'll pull this cover just pops there, and the multi-plug is down in there. That's it hiding down there. So we'll start disconnecting and just pull this airbox out, and we'll see if we can get a test on this. Anyway, the airbox out of the way, we can see this thing. It's pretty easy to get at, but it's the routing of the wiring is the problem here by the looks of it. So it's just buried under here to the front of the car. So I'm just going to have to move a lot of this stuff out of the way to get at that. There's a wee bolt there with the coolant pipe, so we'll start with that, and we'll take a few of these vacuum pipes away out of the road. Right, a load of disconnecting later, and we've finally been able to get at this thing. So we'll just have to disconnect everything nearly to free it up, free the wiring up. So that's our plug going to our exhaust gas temperature sensor, and we'll just do a wee quick ohm measurement on it. So we'll put these on there like that. We're getting 0.78 megohm, so that's more or less open circuit. So that's good enough for me. That's your fault. So we just need a sensor. The only pain about changing this is, like, I think that'll come off okay, but this wiring is just trapped. I have a load of stuff disconnected, but the plug won't pull out, so I just have to disconnect more stuff to try and get enough room for for the wiring to pull through. Right, that's us now. I moved a boost sensor up here out of the way, so the wire will now feed through this conglomeration here, hopefully. I'll poke it through on fingers and thumbs, and there we go. So, just need to crack that nut there. Shouldn't be too difficult, hopefully. Famous last words. Just tight. And half. I'll have to see if we can get a wee bit more purchase on it. So the open ender, you know, it's just opening the open ender. So let's see if this will loosen up for us. Lovely. So we'll have a replacement, and just to confirm, we'll test this one. And there's the part number that's written on that exhaust gas temperature sensor. A008 153 2228. You can see that right? There it is. Just a point to note, this uppermost exhaust gas temperature sensor is different from the one down at the DPF, so you need to make sure you get the right one. We'll just do a quick test of the new one. They're front probe there, but they're just touching and no more. So we're reading 209 ohms. This one here was reading, what was it, 7 mega ohms. So it's basically open circuit. So we'll put a wee bit of heat on it and see what happens. And the temperature rise is increasing the resistance. So this is a positive temperature coefficient temperature sensor. So a wee bit of component information, exhaust gas temperature sensor there, component information. Let's see, exhaust gas temperature sensor, 2-pin connector with fly lead, contains a temperature dependent resistor or thermistor. Resistance increases as temperature increases, commonly known as PTC or positive temperature coefficient resistor. Changes in resistance can cause changes in signal voltage. The voltage is interpreted by the ECM as exhaust gas temperature. The ECM uses this signal to ensure conditions are met for particle filter regeneration. So I think that's just the same again there. So, there we go, our testing proved that to be correct. So as we can see, on a positive temperature coefficient, as the temperature increases, the resistance also increases. So as the temperature goes up, the resistance goes up. So with an open circuit, a high resistance, you're going to read the high temperature. So on the live data, it pegged out at its maximum at 850 because it was open circuit. And conversely then, a negative temperature coefficient, as the temperature increases, the resistance goes down, and vice versa. So when the resistance goes up here, in this case, the temperature goes down. So you can see that quite a bit if you disconnect a coolant temperature sensor or an intake temp or something, and it goes open circuit, and it usually pegs low at -40 then. So the live data from the initial DAG then basically told us that that was a positive temperature coefficient sensor there. So we heard anti-sneeze on it. We'll get this thing fitted. But do you ever feel as if you're being watched? Anybody want to buy a TV? Right, that's her all back together again, and We'll run our scan, clear the codes. So far so good. All codes cleared, and we'll just take a wee look at the live data. Okay, so there we go. So since we put that in, it's now the engine coolant temperature 17 degrees, so the car's stone cold. So we've cooled down a wee bit. It is in the evening time I'm doing this, so and it's in December in the winter. So there's our two exhaust gas temperatures there, 16 and 15. So a bit of difference there from 850 that it was pegged at before, the B1911. So yeah, that looks like a fix to me. So we'll take it on a test drive and we'll confirm that fix to the customer, and hopefully he should be on his way. Regarding our previous repair in this car, I don't believe this is related to, you know, it was the DPF was full because there was a boost leak, so I don't think it's related at all. Customer's happy enough for that, so that's it. Okay, I think that's it for this one then. Many thanks for watching, and yes, I did get it full screen after a while, so I got rid of that annoying person that's in that. So I managed to go into it and I turned them off. So I don't know how I got into that anyway. So yeah, okay, thanks for watching as ever, and all the best, and